Hi, here I am going to discuss Semester 3 Mathematics for Computing 2 2016 Paper 1 question number 6 to 10. Question number 6. Here we have to deal with m number of equations which are consisting with n number of variables. So we know that all these coefficients are real numbers and they have given that the system is homogeneous. If we have this type of simultaneous equation system, we can convert this thing into the matrix form as Ax equals y, where A is the coefficient matrix, x is the variable vector and y is the right hand side coefficient vector. So y is equals to y1, y2 up to yn, a column vector. If it is homogeneous, definitely we know that the vector y will be equals to a 0 vector. So this will be reduced to the form Ax equals 0. So when we have a homogeneous system, we know that always it is a consistent system. And also we know that there will be an answer which is the trivial solution. Trivial means the solution where all the variables, all xi variables, unknowns equals to 0 will be a solution. So A correct since the system is consistent when we have any homogeneous system. Definitely then B will be incorrect since the trivial solution becomes a solution for the homogeneous system. C will be again correct since x1 equals all the variables equals to 0 is always a solution, that is known as the trivial solution. So for consistent system we know that you may have two cases, when we have an unique solution and when we have infinite number of solutions. So D is incorrect because we don't know whether the system is having an unique solution or not. It may have an unique solution and it may have an infinite number of solutions, since these two are the main two cases for a consistent system. So E is correct since the system may have is there, may have infinitely many solutions. So the answer is A, C and E. Question number 7. Let I be the identity matrix of order n. Which of the following is true about I? A. I is the diagonal matrix. Yes, it is, because we know that I is a square matrix of order n. Suppose we have 2 by 2 1, then definitely in the diagonal you will have 1. All the other elements will be equals to 0. If we have a 3 by 3 identity matrix, then we have 3 ones in the diagonal. All the other 6 elements will be equals to 0. So by default it is a diagonal matrix. I is a symmetric matrix. Yes, it is. It is symmetric over its main diagonal. Always Aij equals Aj equals 0, where I not equals j for any I. So it is symmetric. What about E? I to the power n is equals to I. Yeah, same as in real numbers. 1 to the power n is equals to 1. In matrices, the identity matrix is refers to as 1 in real numbers. So I to the power n is equals to I as it is. For example, when we multiply 2 by 2i by itself, then what we get is 1001, same I. So the answer is A, B and E. Question number 8. We have a 3 by 3 matrix capital A. We have to build up a relationship between these given determinants and the determinant of the given matrix. Let's focus on the choices from A to D. For the matrix capital A, let's say this one as row 1, row 2, row 3, column 1, column 2 and third column. So for part A, we can get this matrix by interchanging second row of A with third row of A. For part B, we can get this by interchanging second column with the third column. We know that if you have any matrix capital A, if its determinant is denoted as determinant of A, and if we have another matrix capital B, by interchanging two rows or two columns. So you may have this case R2 interchange with R3, or you may have an interchange between a column and another column. In that case, what will happen is determinant of B will be minus into the determinant of the row matrix given, capital A. So based on that, if it is determinant A, this will be minus into determinant of A, since we have an interchange between two rows. Similarly for part B, this will be same as the determinant of A, not exactly equals to the determinant of A. So these two incorrect. So what about C? For C, we can get this by interchanging R1 with R2 and then the second row again with R3. We have done two interchanges. So in that case, we have to multiply the determinant of A twice by minus 1. So in that case, the determinant of the matrix given in C will be exactly equals to determinant of A, because this is equals to minus 1 into determinant of A. You will have always minus 1 when you have one interchange. Since we have two interchanges, you will have minus 1 twice as a multiplication between those two. So it becomes again same as determinant of A. So C is correct. That is exactly equals to the determinant of A. Similarly for D, we can take this matrix by interchanging first column with the second column and again the second column with the third column. The previous rule will be true for the interchanges if we do within columns. So in that case, by the same argument, you will have the determinant of this matrix as determinant of A itself. That is also true. So D will be a correct answer. Similarly, we can check E. For E, normally, generally, we have two identities. For the multiplication and its determinant is equals to the multiplication of the individual determinants. But in generally, determinant of A plus B is not equals to determinant of A plus determinant of B. But there are some cases that we have this identity as true. So we have to check this. Determinant of A, we can expand over the first row. Then we have 8 into the minor of 2. Minor of 2, first row deleted, first column deleted. Then we have minus 22. Minus 9 into its minor. First row neglected, second column neglected. Then we have 3 minus 35, that is minus 32. Similarly, we have plus 2 into minus 18. Then the answer is 76. Similarly, we can find the determinant for this matrix. That is equals to 8 into its minor minus 9 into its minor plus 1 into its minor. 3 minus are minus 24. When we neglect first row and the second column, we have minus 30 and then we have minus 18 again. So the value is 60. And again, we have to find the determinant of this matrix, that is equals to 8 into its minor minus 9 into its minor plus 1 into its minor. Minor of 8 is, by neglecting first row and the first column, we have 2. By neglecting first row and the second column, we have minus 2. And here again we have minus 18. So the value is 16. So when we get the summation, here we have 60 plus 16, that is 76. So those two are equal. Then again E will be true. So the answer is C, D and E. Question number 9. Here we have a recursive function for the n plus 1 term when first term is given. So from this we can have the recursive function for n plus 1 term as 1 minus xn. So when n equals xn values, when n equals 1, xn plus 1, that is x2 equals 1 minus x1. Then we have 1 minus 2, that is equals to minus 1. When n equals 2, we have xn plus 1 as x3. Again, 1 minus the previous term. So we have 1 minus minus 1, the previous term. That is equals to 2. When n equals 3, xn plus 1 is x4. That is 1 minus previous term is 2 equal to minus 1. x5, that is 1 minus the previous term is minus 1. Again we have 2. So we have a sequence of 2 minus 1, 2 minus 1, 2 minus 1 again. By starting from x1, x2, x3, x4, x5 and so on. x1, 2, minus 1, 2, minus 1 alternatively. So see here, when n is even, we have minus 1. When n is odd, we have plus 2 always. So, xn, when n is even, we have minus 1. When n is odd, we have plus 2. Asking about x100, where n is even, because 100 is even. So that should be equals to minus 1 according to this. It is there. C. So the answer is C. Question number 10. We have to consider 3 terms of an arithmetic series. Third term, fifth term and eighth term. So suppose we have T3, T5 and T8. Then these 3 terms will be 3 consecutive terms of a geometric series. So we have to find the common ratio. When we consider the arithmetic series, then here we have T3, T5 and T8. Suppose the third term as P and the common difference as D. If the common difference is D, fifth one, in terms of P and D, we have P plus 2D. Similarly, eighth term is P plus 5D. When we consider a geometric series, if these 3 are consecutive terms of a geometric progression, then we know that the difference between consecutive terms will be the common ratio R. So, we have 2 relations. P plus 2D over P is equals to P plus 5D over P plus 2D. That is equals to R. I mean, since these 3 are consecutive terms of a geometric progression, we have T5 over T3 same as T8 over T5, which is equals to the common ratio. So we have 2 relations because this one equals to R and this one equals to R. When we consider the first one, we have P plus 2D equals PR according to the cross multiplication. So we have P minus PR as minus 2D. According to the second relation, we have P plus 5D as PR plus 2DR. So we have P minus PR here, 2DR minus 5D. We can substitute this thing in the left hand side. So 4P minus PR, so we have 2 minus 2D. Then there is 2DR minus 5D. D will be cancelled since it is non-constant arithmetic progression. So D is not equals to 0. So you can divide by D. Then we have minus 2 equals 2R minus 5. So 2R equals plus 3 and R equals 3 by 2. So A will be the answer. So answer is A. See my next video for question number 11 to 15.